My name is David Enrique Garcia Cruz, and this presentation is for the extra points for the Kim and kruskal comparison with the algorithms. My English is not so good, and I try to do my best. So, make an introduction. Oh, let's not change page. I don't know. Yeah, something. The introduction. Well, in this presentation, we'll talk about the comparison between the Prim and kruskal algorithms for the generation of minimum spanning trees, analysis of random graph with vertex augmentation. So, in this presentation, the comparison between the Prim and kruskal algorithms in the generation of minimum expression trees will be addressed with an increase on the number of vertices. So, I'm gonna talk for first for it one algorithm first, and then make the comparisons. So, in the Prim's algorithm, is a gradient method that constructs minimum spanning tree for a initial vertex. This algorithm focuses in adding the closest vertex and already constructed tree, ensuring that the total cost of the edges is minimal. And I'm going to talk about the algorithm. So, as implementation, you call the log of E. And kruskal algorithm is also really approach, but operates differently. You start with set or artist and sort them by weight. Then add the lightning edges and to the tree, avoid the formation of circles until the minimum expansion tree is completed. So let's check the efficiency comparison. That's when comparing the efficiencies in both algorithms, it can be seen that Prim is more effective and dense graph, while kruskal excels is per graph. This difference is due to the way in which each algorithm handles edge and vertices. This have some examples. For example, in number, these are the original graphic. You can see this part. The tree with less weight. So I'm gonna talk differently because the Prim the is the other problem requires working with a graph stored and adjacent matrix where adjustment edges can be easily required. And kruskal is per edge and already product of the graph and represent as a list of edge. So making a analysis of the graphs, we can see that the practical example we tested, the example we do in Collab that for a practical example we tested with 5,000 random graphs with a range of 5 to 100 nodes. Then each algorithm solved it of the graphs and then the graph of the result. The experimental result does the test give us the kruskal has an overall lower time execution, while Prim's algorithm shows that more dense graph and tends in more quadratic time progressions. So this is the comparison that make it in collab that execute, and this is the result. If you can see, for example, in kruskal is so the graphs is don't elevate so much fast the graph, and the is not elevate the graph and comparison of print algorithm. For example, in other one, make the in the collab and make the execution that I tell, and sorry. Premise algorithm kruskal is the difference is the that kruskal algorithms make up so elevate compare with Prim's algorithm. For example, in Prim's advantage and disadvantage is that essentially of dense graph works well. Dense graph science it analyze of the only edge connected to the tree and each iteration, and disadvantage is need to connect to the graph. Is the graph not connected, you cannot construct. That what can say about that is they are not connected, they don't work so well. So it's different how may to comparison. Some the premise compared connected like a cable with a TV that if not connected don't work. This is a little example. And let's talk about kruskal advantage and disadvantage. That in kruskal, efficiency of sparse graph is more efficient with a spare graph. Since its process is increasing in order without analyzing unnecessary connections. What can say about this is that in comparison that Prim is that the kruskal don't need to connect all of the points and only the importance. It's like you want to make a presentation with the more important things. is a little example. And the disadvantage is additional structure for loops. You need to structure like union find to avoid loops, which via an additional complication implementation. Less efficient and dense graph processing all edges and checking circles for be more expensive and dense graph. And this link for the collab I want to change. And for example, this change make the execution. For example, import the required libraries, then make the functions. Then the premise algorithm implementation. They make the implementation, and now is the kruskal algorithms. I'm gonna upload this in the presentation final. So this we need to in this part generate the 5,000 random graph, and then the plot comparisons that make the points to see what is the difference between Prim algorithm and kruskal. Uh, make the comparison with time and nodes that we can see. It's the same graph in the presentation, only that is so small. And this is the steps and nodes, and make the comparison. Is I try to we try to make so different, so large to make, but you can see the most comparison because is we make the more cases, no, little cases, we cannot see the difference. So that is the reason that makes so uh, inferences and time edge, steps and edge, and that's gonna make the comparison and then graph the things, and then see what steps take, and in the other ones is how the time, and then repeat the same. So is this for the presentation for the extra points of the Prim and kruskal comparison of these algorithms.